Hi, this is Asing. You are now watching Asing Math TV. Today we would like to share how to perform chi-square goodness of fit test by using SPS. Consider the problem. We are going to test whether there is a special preference in the selection of fruit juice among the customers. Our intention here is to check on the selection of fruit juice instead of the frequency. So which means that the favors is very important here. We must have a column to record all the favors and one column for the respective frequency. Next, go to data, click on weight cases, and we should weight according to the frequency. Click on OK, all the data should be weighted by frequency. Now let's proceed to the test. Click on Analyze, look for non-parametric test, click on One Sample. Go to Fields. Under the Test field, we need only the favors since we are going to check the selection. Remove the code. Go to Settings, click on Custom Test. Check Compare Observed Probability to Hypothesize Chi-square Test. Click on Options. Look for all categories have equal probability. Since we are going to check whether there is a special preference. If no special preference, which means that there should be equally distributed. So which means that all categories will have the same probability. Click on OK and proceed to the text option. Check the significance level. We want to test at 5% level of significance, which is correct. And click on Run, we should obtain the result. Unfortunately, when we double-click on the table, we will realize that we are not able to change the number format. We are not able to increase the number of decimal places. For the significant level, the p-value, as well as the test statistics. This is the limitation of this approach. Let's try for another approach. Go to Analyze, look for non-parametric test, Legacy dialogs, and click on chi-square. Unfortunately, we face another issue here where we are not able to find the flavors. This is because by using this approach, we should make sure that all the data given must be in numerical form. So which means that we should transfer the flavors which is in text form to numerical form. We can give a code for each flavor, and we just have to go to the variable view and assign the value accordingly. Under the values, click on the button and we are able to label accordingly. Click on OK, and now we should be able to perform the test. Analyze, non-parametric test, legacy dialogs, chi-square. Move code to test variable list. Check all categories equal since we expect no special preferences. Click on OK and we should obtain the result. And for this method, we are able to change the number of decimal numbers. Double-click the table, select the number, right-click, look for cell properties, and we can go to Format Value and increase the number of decimal places accordingly. Click on OK and we should have the number of decimal places that we want. From the result, we obtain test statistics is equal to 43.896 and the degree of freedom is equal to 3. Degree of freedom is obtained by using number of groups minus 1. As we can see, we have 1, 2, 3, 4 groups here, minus 1, we obtain 3. To obtain the critical value, let's make use of a new data pool. Go to File, New Data. Make sure the data view is not empty. Simply type any number. Go to Transform. Click on Compute Variable. Simply type any letter under target variable. We need inverse TF. Look for chi-square up. The first question mark is the significant level. For this case, we have 0.05. We should always bear in mind that SPS always take less than cumulative. Instead of taking 0.05, we should take 0.95 for the less than region. More than, we have 5%, which means that less than, we have 95%. And the degree of freedom is equal to 1, 2, 3, 4, 4 minus 1, which is 3. Click on OK and we should obtain the critical value. From here, we can see that we have 7.8147. And the rejection region is always reject the hash null whenever the test statistics is greater than the critical value. Based on the test statistics that we obtain, since the value is greater than the critical value, which means that we should reject the hash null. And that is sufficient evidence to conclude that there is a special preference in the selection of purchase among the customers. For the p-value approach, always bear in mind that it's not a good practice to write the p-value is exactly equal to 0. This is because SPS may not have enough space to displace the non-zero digits. So we should use approximately equal to 0, and this value is less than the significant level, which means that we should come to the same conclusion. Now let's try for the second example, and this time we assume a certain probability distribution. We should first obtain the expected values for each category based on the probability distribution. Next, go to analyze non-parametric tests, legacy dialogues, and we look for the chi-square distribution. This time we should use expected values. We should follow exactly the distribution here. The category, first one is 210. Follow the sequence. Sequence is very important, otherwise we will result in the wrong output. 338. Next, we have 258. And lastly, we have 210. Click on OK and we should obtain the result. As we can see, 204 compared with 210. Check, correct. So which means that the order when we enter must be correct, otherwise the result will be wrong. This time the test statistics is less than the critical value, which means that we could not reject the null hypothesis at alpha equal to 0.05, which implies that the preference in the selection of approaches follows the given probability distribution to some extent, which is 5% level of significance. If you want to apply the p-value approach, can obtain the value directly from the table, since this is for one till only, which means that as we compare with the significant level, we shouldn't reject the hash null for the same reason, and we come to the same conclusion. Okay, that's all for this video. Thanks for watching. Hope you like this. See you.